This conference will now be recorded.
Okay, so Deepa, this is the second lecture on this topic wave optics. We had already started with this. I think you just missed the first class of it, I think. Anyway, today what we are going to learn is superposition principle of waves or principle of superposition of waves. Then coherent incoherent sources and constructive and destructive interference of waves. Okay, so see, this is actually the basis of today's concept. Whatever we'll be learning today will be the basis of interference of light. So today we'll see interference of light. Actually, light is an electromagnetic wave, and today we are going to learn how more than one waves, okay, more than one waves, when two or maybe more than that number of waves are like more than one. So when a number of waves they they travel in the same direction in a medium, and then they meet at a particular point. They meet at a particular point, that is called superposition. Okay, meeting at a particular point is called superposition. Okay, so look what happens when, suppose I have a medium, particular medium. I'm just considering some particular medium in this. Okay, so there is a point here P. Okay, and there are many waves which are traveling towards this point. Okay, you have to understand that the waves may be of same amplitude, maybe of same frequency, or maybe different amplitude and frequency, doesn't matter. If suppose there are waves, they are traveling in the same direction and they are meeting at this particular point. Okay, so this meeting at any point is called superposition. Now you might be thinking, sir, what is the principle of superposition then? So superposition principle states that when a number of waves traveling through a medium superpose on each other, the resultant displacement at any point at a given instant is equal to the vector sum of the displacements due to individual waves at that point. I'll just draw the same figure again. What does it mean? Let us see with it. Okay, so yeah, let me. Okay, so let me tell you one thing. Here there is word displacement. See, you might be aware of the equation we write for a wave. Suppose A is equal to sorry, y is equal to a cos of omega t. Okay, you know what this is, what is y, what is a, what is omega, and what is this function. So we have seen in class 11th, any periodic wave, okay, any periodic wave can be expressed in terms of cosine or sine, okay, in or a sinusoidal as a sinusoidal wave. So that part is this cos or sine or whatever comes. What is this y? Actually, if we think of an elastic wave, then what happens? There will be a source of like you have a sound, source of sound. So what happens when there is a source of sound and the waves produced? So it needs some medium to propagate, obviously, and when it propagates through a medium, what happens? The particles of the mediums are actually disturbed. Okay, particles in the mediums are disturbed. They were suppose lying like this at any point. Okay, in this line, suppose it was lying, but when a wave comes through that, because a wave means what? It will be actually uh, oscillating in between maximum and minimum amplitude. What is amplitude? This is called amplitude. And let us see what this mean. So this means actually the waves has displacement. This is actually displacement. So when the wave is actually propagating through a medium, it is displacing the particles in the medium. So this is the displacement. So these are the displacement of the particle in the medium. Or in case of electromagnetic wave, what oscillates? That is the electric vector that we have seen in the 8th chapter, electric vector and the magnetic vectors. Okay, electric and magnetic vector, they oscillates. So oscillation means what? They will go through they will go through a maxima and minima. See, this is minima and this is maxima. So the displacement, the maximum displacement is called amplitude, so which is written here. So the displacement actually, when we express any wave by such equation, we mean by y, or sometime it will be maybe some other, so x or y or something else, whatever it is. So this is actually representing the displacement of the particles in the medium, or in case of light wave it is the electric vector or magnetic vector. Okay, magnetic field vector or electric field vector that is oscillating and that is passing through the value of maxima and minima, passing through. So oscillation means, see, oscillations, if I just tell you for a simple pendulum, so this is the mean position, and oscillation means, and periodic oscillation means, see, they will periodically, suppose this is your position A, this is B, and this is C. So if you just leave the bob from here, suppose this is a simple pendulum. Okay, this is theta, this is also theta. And if you leave from here, it will first go to B, and then it will not stop here. It will go A, sorry, go to C, and then from C again it will come back and it will repeat the motion like this. This is called periodic motion. Periodically, it is actually tracing the same path. Okay, this is called mean position, and this is called maximum displacement, which is denoted by A. This is amplitude. Okay, maximum displacement is the amplitude. I mean to say this is the expression for the displacement of the particle, which is actually in motion, or yeah, in motion when wave passes through that particular medium. Okay, so this was the case, what is called this displacement. Now suppose, according to superposition principle, if you have more than one wave, suppose this is a point where it is just meeting, Okay, all the waves, suppose this, I'm just taking two waves. Okay, two waves at this particular point. So look, according to superposition principle, when I have, suppose this is displacement, having displacement of y1, this is having displacement of y2. Okay, and when it passes through this particular point, individual waves will be actually displacing this particle according to their displacement. That means at any instant of time, how many number ever waves passes through that or meeting at this particular point, each and every wave will keep their individuality. That means this particle will be displaced by this particular wave by y1, this particular wave by y2, and this particular wave by y3, as if they don't see the other two. Each an individual wave will displace this particle according to their way. Okay, they don't see the effect of the others. Okay, this the same principle, superposition principle, we have seen in case of electrostatics when we calculate the electric or electric forces for, or electric field for, like multiple charges. We take the effect of two at a time. We just don't see others. Similar to that, here, when multiple number of waves are superposing at a particular point of a medium, the displacement of the particle, resultant displacement of the particle, will be the sum of the displacements produced by individual wave. Okay, I have taken three. I can take maybe n number of waves. Okay, so each of them will produce displacement individually, and you have to take the, actually it is vector sum, because displacement will be vector quantity. It will be the vector sum of the displacements due to individual waves at that particular point. So this is actually your superposition principle. So what is the main point you need to note to have superposition principle followed? They have to actually travel in the same medium. They have to travel in the same direction also. If some like this and someone, same direction in the sense, they should actually, yeah, so if somebody is just traveling like this, so they may not interfere. Same direction in the sense, some wave can come from this side. Okay, I'll just tell you. So if some wave is coming like this, and maybe some wave is coming from this side, that is fine. So they are moving or traveling in the same direction. Okay, sorry, same towards same point where they will meet. So this is one condition. Otherwise, their amplitude can be a1, a2, different. Frequency also can be different. Okay, so this is briefly superposition principle what we have learned. Then resultant displacement will be y1 plus y2. So here you might be thinking, so this I am saying as vector sum of the displacement produced by individual waves at that point. That means, so this sum is vector sum. It is not like only a plus b or something like that. It is actually vector sum. I can write like this. So there can be, so this can be vector sum, means this can be either a plus b, or it can be a minus b also. So what I mean to say is, if I take the amplitude of these particular displacements, so it can be either I1 y1 plus y2, or y is equal to, so this is the resultant displacement of the particle at that instant. So this can be y1 minus y2 also. Okay, so this vector sum means it involves both additive or addition or subtraction of the amplitudes. Okay, now you might be thinking, you might be having a question, sir, when they will have this value, when will they add to each other, when they will like one will be subtracted from the other. Displacement of displacement produced by one will be added to the other one, and when the displacement produced by one will be subtracted from the other. So before I tell you this, let me tell you there is something called phase in wave. Okay, phase. So as I had written here, y is equal to a sine or cos. I'm writing here sine or cos. Maybe I'll write cos. Let me stick to the same expression, cos omega t. So here this factor is called phase factor. Okay, phase means what? The factor or the quantity which can tell you the situation or all, in fact all the informations about the motion. Okay, so that is called phase factor. So phase factor gives the information of its motion at any time. Okay, its displacement at any time. Okay, so as we go along we'll learn again. Okay, so this is the term. Now what I was trying to say, when they will add to give resultant y, and when they will they will be subtracted to get resultant, so that we have to find out. So in this case you look, when two waves are like two superposing waves, their maxima and minima are overlapping. These are maxima, these are minimas. So when they actually vibrate in such a way that their maximas are occurring at the same time, same places, or minimas are occurring at the same place. So these two waves are called or said to be in phase. So I think we have discussed this before also. When there are two waves and the maximas, the maximum displacement or minimum displacements are happening, or maybe zeros, not only maximum minima, even zeros are also happening at the same place or same time. Okay, so those are called in phase. Now look this waves. See, when there is a maxima at this place, there is a minima for this wave. If I just say this is wave 1 and this is wave 2, so look, this wave 1 has minima at this place, whereas your wave 2 has maxima at this place. So these are called, actually these two waves are 180-degree out of phase. They are 180-degree out of phase. If you say, see, when the minima 0 over here, the maxima for the wave 2 here, okay, at the same place. So then these waves are called 90-degree out of phase. That means they are out of phase. So this is like in phase when zeros and maximas and minimas are occurring at the same place. They are called in phase. And when the waves are actually not in phase, their maxima, minima, and zeros will not occur at the same place. If the maxima occurs at any place for wave 2 and at the same place, if the minima is occurring for the other, then it is called 180-degree out of phase. If the 0 is occurring for 1 and at the same place maxima is occurring for the wave 2, then these two waves are called 90-degree out of phase, as you can see. So there is a partial phase cancellation, it says. Okay, let us see what is the relation of this in phase and out phase business to our this discussion. Yes, there is a relationship. So see, let me tell you, this is called crest. The maxima are called crest, or peaks are called crest, and this this actually this is called trough. Okay, trough and crest. Okay, this is called trough. T R O. This is TROUGS. Trough. Okay, crest and trough. All right. So if you want to get the wavelength, so the wavelength has to be measured between two crest or between to throw. That will give you the wavelength of the wave. Okay, or wavelength means the, yes, the length of the complete cycle. Okay, that is actually wavelength. Lambda, wavelength is denoted by lambda. Any of these you might have already learned. Just to recap, what is called in phase, what is called out of phase. Now what we'll do, see, when two waves are in phase, look, two waves are in phase. See, maximas are occurring, minimas are occurring at the same place, zeros are occurring at the same place. So when such waves are superposing on each other, the displacement will be additive. So I have taken 2. So here y1 plus y2. So this will give you maximum intensity, maximum amplitude. Okay, I say maximum amplitude of the displacement. Okay, maximum amplitude of the displacements. Okay, so this will give you additive, like addition, when the two waves are in phase, they are meeting in phase. So they are meeting in phase. Okay, suppose this means, like you have plus 5, and at the same time you are adding with that minus 5. Okay, so minus 5, so it will give you 0 definitely. Okay, so this is the case here. Okay, if you add a plus 5 with a negative 5, then it will be 0. So this is the case in the second case. Okay, and when you have both plus 5 and plus 5, you get 10, right? This is the thing here. And now when the waves are out of phase, 180-degree out of phase, then you will get 0 intensity over here. Sorry, 0 displacement, or amplitude of the displacement will be 0. As I told, plus 5 and minus 5 will give rise to 0. Okay, so this is actually resultant displacement y1 minus y2, suppose. Okay, so what we have learned, when a number of waves traveling through a medium superpose on each other, the resultant displacement at any point at a given instant of time is equal to the vector sum of the displacement due to individual waves at that point. And when the waves are meeting in phase, the amplitude of the displacement will be maximum. When the waves are meeting out of phase, 180-degree out of phase, the displacement will be, actually I'm saying 0. I'm just supposing that the amplitude and the frequencies, both of this displacement are same. That's how I'm telling you 0 over here. Otherwise there will be cancellation. Suppose I have 5 and minus 2, like that, this will be 3. So then you can get, so here in this case the amplitude of the two waves are same. Okay, or the displacement y1 and y2, they have same amplitude. If they have same amplitude, like I'll write here a sine, okay, let it be sine omega t. Frequency also suppose same, y2 also a sine omega t. So in such case you will get 0. Otherwise, if this is a1 and this is a2, suppose one is greater, another, like a1 is greater than a2, then there will be partial cancellation, and instead of 0, maybe you will get like minimum amplitude, like this. Okay, not maybe like this. Okay, you'll get partial cancellation if the amplitudes are not same. If amplitudes are same, frequencies are same, then they will cancel to give you 0. All right, so I hope there is no confusion over here. What is superposition principle and what is called superposition? Superposition is nothing but meeting, in our general language, okay, in a medium, and that time the displacement will be, like the resultant displacement at any point at any instant of time will be the vector sum of the displacement produced by individual wave. Okay, all right. So now we'll just go to another concept, which is coherent and incoherent sources. Okay, so what are coherent and what are incoherent sources? And then we will discuss constructive and destructive interference. So actually interference means like superposition only. We'll just tell you, mathematically we'll show you what is called superposition and what is called interference. So superposition, you have seen this here. So actually interference is the phenomena of superposition of two waves, but in that case, to get interference, you should not have coherent, like you should not use incoherent sources. You should use coherent sources, like any sources of waves. If they, like, if there are two sources, S1 and S2, okay, and they arbitrarily send waves and they superpose, then actually they cannot produce interference pattern. We'll show you what is interference. Okay, let me first discuss what is called coherent and incoherent sources. Before I define formally, let me go with an incident. Okay, so suppose, see, this is a trough of water. Okay, water, and you have two needles, two identical needles, identical needles. Okay, now if these two identical needles are made to go up and down periodically, up and down periodically, and in identical fashion, in identical fashion. See, there are few words you have to note. In identical fashion. Okay, so what I'm saying, there are two identical needles. They are made to periodically go up and down into the water surface. Okay, into the water, up and down, like this, go like this. Okay, up and down in identical fashion. Like, see, suppose in 10 seconds it is going down maybe 10 times, so the other one also has to be like that. Okay, if it is going, like, going into the water 10 times, other one also has to go 10 times into the water. Okay, and same depth and all those things. So this is called identical fashion. And if such happens, if you can do that, what will happen? As you have seen in case of the definition of wave front, that at the point of impact, at the point of impact between the water and the needle, there will be waves created. And these waves are, like, these are spherical waves, wave fronts, actually I can say spherical wave fronts will be created, and they will be spreading out like all directions from the 2 points of impacts. Or this, you can think of the sources of water waves, these 2 points, S1 and S2, where they are just impacting or interacting with the water surfaces. So these two sources, this you just take as sources of water waves, which will be produced by the impact or disturbances created by this ups and down motion of the needle. And they, as you look, they will be spreading out in identical fashion, because, see, since our needles are identical, they are like they are made to move up and down in an identical fashion. So the waves they produce also will be identical in fashion, in the sense the frequency will be same, the amplitude will be the same. Okay, and see, one more point is their speed. So if the amplitude, frequency, everything is same, the speed also will be the same. They will be actually spreading out in all direction with the same speed, same kind of speed. Okay, because the medium is the same, water. Now what will they do? They will actually meet each other. They will meet each other. As you can see, they are meeting at this point, at this point, at this point. Okay, they will be meeting each other. Okay, so when they meet each other, depending on whether they are meeting in phase or out of phase, they will produce nodes and antinodes, as you can see from here. So they will produce nodes and antinodes. Okay. Okay. Before that, let me tell you, since these two needles are identical, the waves are created in an identical fashion. The waves will be identical to each other. That means your frequency amplitude will be the same, right? And at the same time, they will be traveling same distance in same time. Okay, equal time, in equal time. If this happens, or maybe suppose there is this wave and another one is this wave for this source. Okay, S2 source. If I take this wave and for the S2 I take this wave, they have particular time gap to reach a particular distance. Okay, so if you take any point P, suppose this one is at the perpendicular, at the distance perpendicular bisector, on the perpendicular bisector. So this distance S1P and S2P will be the same. So this distance is called, see the distance, this is called path that it travels. S1P and S2P are the paths they travel. Both the waves produced by S1 and S2. Path of travel, or we can say, yeah, we can simply say path or path of travel, just to remember. So these are called path S1P and S2P. So if I take another point anywhere, suppose here Q, so this distance you look S1Q and S2Q may not be the same. Okay, may not be the same. Okay, this S2Q and S1Q may not be the same. I can take another point, maybe R here. So here also S, this is R. May see S1R and S2R may not be the same distance. So their path may be same or may not be the same. Path traveled by each wave, okay, produced from S1 and S2. And if the paths are not same, or anyway, if they are same also, so you can find out the difference between the path. Okay, S1P minus, I don't know which one is greater, which one is less. So I can give a difference sign S2P. So this is called path difference. When you just find out the difference between the path length, this is called path difference. Okay, this is called path difference. Okay, so this is called path difference. I hope what you have understood what is called path difference. Okay, the path traveled by each wave is called path difference. Now look, if if there is, see, since they are identical and the waves are actually formed in identical fashion, so wherever they go, wherever they meet, they have they have a constant phase relationship. Phase relationship. I'll explain once again. Relationship. Constant phase relationship. Okay, and such sources are called coherent sources. Coherent sources. Such sources are called coherent sources. Okay, coherent sources. What do you mean by coherent sources? If the waves produced by two sources maintain or have a constant phase relationship, that means suppose they have initially, see, suppose the S1 is creating a wave which has displacement a cos omega t, cos of omega t. Other one is creating a cos of omega t plus phi. Okay, so phi is the phase difference between them. If wherever they meet, whether they meet at P or Q or wherever, if the phase difference, okay, sorry, not phase difference, the phase relationship is remaining the same. Suppose, see, they according to the path they travel, the phase difference actually defined as d phi. Phase is denoted by phi, and phase difference is denoted by d phi. That means phi 2 difference phi 1. So this phase difference is actually expressed as 2 pi by lambda into path difference. Path difference. Okay, path difference. See, path difference can be expressed difference can be expressed in terms of wavelength. Okay, wavelength, that is lambda. Okay, if you put it here, path difference in terms of lambda, then you will get phase difference in terms of pi. Suppose I say path difference is lambda, then I multiply here lambda, so you will get 2 pi phase difference. Okay, so if I have path difference lambda, so 2 pi by lambda is equal to d phi phase difference. So lambda goes up, so you'll get 2 pi as phase difference. So this is how we'll be calculating the path difference, phase difference also. And see, so let me come to the proper discussion. So two sources of wave, so that can be, see, wave can be light wave, sound wave, whatever, and the superposition can happen between any two waves, whether it is light wave or heat wave or whatever wave it is. Okay, but it has to be periodic wave at least, for better calculation. So two sources of waves which continuously emit waves of same frequency or same wavelength with a zero or constant phase difference between them are called coherent sources. Okay, yeah, so constant phase difference, or I will say constant phase relationship, in the sense, uh, when suppose phase, in the beginning phase difference was pi. Okay, after certain time it can be 2 pi, it can be 4 pi. Okay, so it is going like that, but see, suddenly it cannot be pi, or maybe it cannot be, uh, so pi by, okay, so we'll just discuss that how this happens. Okay, so at least you should remember that there should be a constant phase difference between the two waves, constant phase difference. Okay, if I say a sine omega t for one wave, another wave phase is sine omega t plus phi, so this phi has to be constant. Okay, if this constant phase relationship is not maintained, then they are called incoherent sources. So let me just write down the definition. So two sources of waves which which have a constant two sources of waves which have a constant phase relationship is like are called coherent sources. Coherent sources. otherwise it is incoherent. Okay, otherwise means if they don't maintain constant phase relationship. Okay, so we'll see it is important to have interference of light or interference of any waves. Okay, so we'll see very soon why we should require interference of waves. So as I was saying you that when these two waves are two sources are coherent sources, coherent sources, that means they maintain a constant phase relationship. Upon this superposition, what will they create? They will create nodes. See, these are the nodes, antinodes. Okay, they will create nodes and antinodes. So these are antinodes, as you can see, antinodes, and some places they will create nodes. Okay, nodes and antinodes. Nodes and antinodes, if you have forgotten, let me remind you. Antinodes means having maximum amplitude when they meet in phase. Two waves meeting in phase. Two waves meeting in phase actually is antinode. Okay, and node when the displacement or amplitude of the displacement is zero, where the displacement is zero. Okay, so at this place actually the waves are having same amplitude suppose, and they meet out of phase. So that's how you get nodes and antinodes. Okay, nodes are having maximum amplitude and antinodes zero amplitude. All right, so these are few things. Now we'll see slowly what are the importance of coherent and incoherent sources. Before that, let me uh, tell you what is constructive and destructive interference. Okay, okay, so to do that, I'll let me first take some specific example, then I'll derive uh, a general expression for that. So let us see this thing. As I said, path difference can be expressed in terms of lambda also. So, so for the same sources of waves, they are producing some waves, and suppose the coherent sources, so S1 and S2, which I have shown there in the beginning, these are coherent sources, and they are producing two waves which are meeting at this particular point Q. And how they are meeting, you look, they have a path difference, right? In fact, one, and let me say this is the one. So look, this length is how much? This is the, if I just take difference S2Q, okay, minus S1Q. Here I know I can write, see S1Q is lesser path and this is the greater path. You can say that larger path, a longer path. And see what is the difference here? See, the wave which is produced by S1 source, it is actually reaching up to Q when it completes 7 complete oscillation. I'll just count for you. 1, 2, 3, 4, 5, 6, and here it is 7. Okay, there are, so, and what is the length of each complete wave? So this complete wave, a full wave, full cycle has a length lambda. This is called wavelength. Okay, so suppose S1, like this, the wave which is produced by S1 source is reaching here after completing 7 complete cycles, whereas the wave produced by this S2 source is meeting here at Q after completing 9 complete oscillations. So you will get the path difference here. Here path difference between these two waves at this particular point, because you have to find out whether the displacement according to superposition principle they will be additive or they will be subtracted. So to do that you need to know whether they are meeting in phase or out of phase. Do you understand what is the purpose of showing this slide and discussing this thing, this finding out path difference, etc.? You need to know whether the displacement, resultant displacement will be positive, like this, or y1. Here let me write y2 and y1, y2 minus yn. Which one has to be written in this case? So that is what we have to find out, whether, like, for knowing that, you have to find out whether these two waves are meeting at this particular point in phase or out of phase. Okay, so to get the phase difference, let me say whether if there is no phase difference, then they are meeting in phase. If there is a phase difference, then they are not meeting in phase. So we can find out phase difference. To find out phase difference, we know phase difference is phi is equal to 2 pi by lambda into path difference. Okay, path difference. And path difference very often denoted by delta. Okay, denoted by delta. So we can write 2 pi by lambda into delta, and you have to find out what is the value of delta. So look, this delta is actually 9 lambda minus 7 lambda. I hope you agree, because this length of this path will be 9 lambda, this path will be 7 lambda, because this reaches here after completing 7 full cycle, and this is actually meeting here at q after completing 9 cycles. So you get here 2 into lambda. So what is the phase difference then? Let me tell you what is phase difference here. So phase difference we have to write, look, delta phi according to this definition, 2 pi by lambda, 2 pi by lambda into path difference is 2 lambda, again lambda lambda goes up, so you get 4 pi. So this 4 pi, you know what is 4 pi? 4 pi means they are in phase. So when phase difference is even number of pi, even pi, even pi, okay, then it is actually even pi means, okay. So what I would have done is, actually I'll just write it here. Uh, so okay, let me write it here. So suppose y1 is a cos of omega t, okay, and y2 a cos of, see, this is having how much phase? So omega t plus 4 pi. What it gives you is cos of omega t only, okay, with the positive sign, not a minus sign. Okay, so I had taken two waves having a cos omega t, a cos omega t, and another one has phase difference 4 pi. So I'm writing like this, and since it is actually uh, going little, okay, so yeah, so yeah, whether it is plus pi or minus pi doesn't matter. Okay, whether it is plus pi or minus pi doesn't matter. It will be actually cos omega t. Okay, cos omega t. So look, if I just get the resultant, you will get y1 plus y2, because see here is plus, so you'll get 2a cos of omega t. Okay, this is the resultant. So I'll write it for this case. So since path difference delta is 2 lambda, and this gives phase difference 4 pi, so which give you resultant displacement as a cos of omega t plus of a cos of omega t plus 4 pi, which is again cos omega t. Okay, so it will give you 2a cos of omega t. Okay, now this is the new amplitude. See, this amplitude is not the same as the amplitude of the individual waves. Okay, so you get greater amplitude, and you look in this case, you will get maximum amplitude upon superposition over here. And so if you want to know if this is a light wave, then you want to know what is the intensity of the light. So intensity of any wave is actually directly proportional to the amplitude square of the amplitude. Okay, square of the amplitude. So if you want me to write what is the uh, amplitude for individual waves, so they are actually directly proportional to, okay, let me write as k, proportional to constant k square. And in this case, the resultant intensity is, suppose, yeah, so resultant intensity is actually 4 into k proportional to constant into I square. Okay, so a square. Okay, so I can write k square as I0. Suppose this is I0, the initial intensity or intensity of the individual waves, intensity of the individual waves. Okay, and this is 4 I0. So 4 times, you get 4 times greater intensity upon superposition. Very nice. Let me uh so okay, I'll just go to another situation. Okay, let me take this one. Let me take this one. You can see there is another point. This is R, where this wave, like wave from S1, is meeting after completing after completing this much, like this is a fractional case. Okay, so S1R is 9.75 lambda. Okay, that means it completed a 9 complete wave, and 75% of 75% of the other wave. Okay, other cycle. And in this case, it is actually completing, this is 2R is 7.25 into lambda. So anyway, doesn't matter, we can just get the path difference delta, that is S1R minus S2R. So here you get, see, 0 and 0.5. Okay, and this is 2.5 lambda. This is the path difference. So I can write this as 5 by 2 lambda. Okay, 2.5 means 5 by 2 lambda. So what will be the phase difference in this case? So phase difference will be 2 pi by lambda into, this is path difference 5 by 2 into lambda. So lambda goes up, 2 goes up, so you get 5 pi. So this you can see, this is the odd pi. So if you write your y1 as a cos of omega t, and another one y2 you write as, okay, in fact this will be having greater. So suppose this is 5 pi, another one is a cos of omega t. This is what. Okay, so see, since this is odd pi, what you get here is a minus cos of omega t. Now if you add this two, what you get is actually 0. Okay, so in the earlier case, what we had got y1 plus y2 as 2a cos of omega t, where they were additive, and intensity was actually uh, given by 4 into I0, 4 I0. Here your intensity will be 0. So here in this case, since this is odd lambda, we have got odd pi of phase difference. So in these cases, the superposition, the displacement or amplitude of the displacement will be 0, or they will be subtractive. Okay, they will be subtractive. If these are not, amplitudes are not same, then at least the displacement, amplitude of the displacement, resultant displacement will be lesser than individual. Okay, lesser than individual, and in this case will be greater than individual. So when they meet in phase, so when it is actually 4 pi, it was 4 pi earlier. 4 pi means even pi. Even pi means they are meeting in phase. When two waves are meeting in phase, then the intensity will be maximum, and this is called constructive interference. This is called constructive interference when two waves meeting in phase. When two waves are meeting out of phase 180 degree, see this is minus, so that means they are 180-degree out of phase, so 4 pi plus pi. So they are meeting out of phase, 180-degree out of phase, then the intensity will be zero. So this kind of interference is called destructive interference. Okay, destructive interference. So from these two, we can find out, a formula that when you have when you have uh, what is the condition? So condition for constructive interference. So what is the condition? So the condition for constructive interference is that when, so the resultant intensity will be maximum when the phase difference between two interfering between two interfering waves is even multiple is an even multiple of pi, or path difference of the two waves is integral multiple of lambda. Integral multiple of lambda. Okay, so that means, see, it will be maximum when your path difference, that means your delta phi, has to be integral multiple of lambda, that is, okay, either 0 or 2 pi or 4 pi, 6 pi, like that, even multiple, or path difference. Okay, path difference, that means delta has to be integral multiple of lambda, n lambda, where n has to be 0, 1, 2, 3, anything. So integral multiple of lambda. I'll just write down the condition for the destructive interference. So condition for destructive interference, destructive interference. So the condition in this case, so phase difference has to be pi, 3 pi, that means odd multiple of pi, or path difference delta has to be 2n plus 1 into lambda by 2. That means where n can be 0, 1, 2, anything. So any integer number. So this means path difference has to be odd integral of lambda by 2. Odd integral. Sorry, odd multiple of. Odd multiple. Odd integral multiple. That is also fine. Odd integral multiple. Multiple of lambda by 2. Or even, sorry, odd multiple of pi in phase difference. Odd multiple of pi. Multiple of pi. Okay, so these things we'll be discussing a little more with general equation, and then that time I'll discuss this locus of these points also. So today it is already time to conclude. Uh, we'll meet again on Sunday. That day we'll discuss a little bit more on this, and then we'll discuss what is called interference from that mathematical expression also. General expression we'll find out, and then we'll discuss once again briefly about this conditions of constructive interference and destructive interference, and few more things on that, and then we'll go for interference of light. Okay, so Deepa, thank you for your patience. It was a long class. I don't know whether you have some doubt. If you have some doubt, you can just ask me now. You can, yeah, you can unmute yourself and ask me. Okay, so these are actually very basic things. I took little longer time, but these are the basic things you have to understand if you want to understand interference. Little more is remaining. I'll just take up this remaining portion on this part again, little bit, and then we'll discuss the interference of light on the next day on Sunday. So Deepa, I'll end it here. If you don't have any doubt, or you may ask today. It is already late. You can ask me in the next class also. Okay, I'm stopping it here, concluding it here. All right. So bye for today.